Hi everyone, and we are back. Last video we did the find element method. So today we're probably gonna focus, we had some problems, but we're gonna focus today on the remove method. So I'll minimize this and let's remove. So how do I remove an element in a linked list? Here, I'll need to search, loop through the list, loop through the list until I find element. If I find it, found, remove, not found, I'll return false here. I'm going to return a true in this case, true. So we have two situations here. One is if it's the last element, which is the last element. Actually, it can be in the start. The element can be in the end. Last end. And it can be in the middle, which is I think is the hardest case to handle. So how do we do this? Let's create a function. Public boolean call remove, and also receives an element. Should I do an element or an index? I think element is easier because an index is going to be hard to deal with. And for now, return false. So again, we would need our walk node. Let's create it with var walk node. Let's just call it node. I think walk node is getting weird. Let's call it walk node. Who cares? Walk node. I type walk. Okay, it's fine. This dot start. How do you guys do it actually? Because sometimes I see people doing this. It makes sense, but when I put this here, it makes it less confusing for me to understand what is going on. But like here, sometimes I forget because we're in the same class, so I can actually use this in their private method. So it's curious. So let's go back here. So we while walk node has next. We actually suggested that. So while he has an X, let's actually do, so we don't make the same mistake again. Let's make sure our node is moving. Walk node dot get next. So now our node is moving. That's good. Now what we do? Now we got into the problem where I told about it to you guys later in the last video. Since I'm not returning the node here, once I try to find the element here, it's just going to return the element and I'm not going to be able to do anything with it. But if I return the node, should I do internal find element? So I can actually do this loop and return the node and I can handle it here. I think it's a good idea actually. Yeah, I think I'm gonna do internal find that returns the node. I think I'll actually copy this. Let's put it up here. I'm gonna call it find. I'm gonna put it private. And here you'll return a node. There you go. In here we're now gonna get the data. I think it's ready. So returns no. I think it's ready. So I don't need to do this here. This is gonna be easier. So I can just simply say, oh, actually not here. What the fuck? That was scary. It's actually here. So I don't need to start him. I can just simply say walk node receives find, and I send the element. What elements to him? So he's gonna be here. It will return the element, and here we handle the situations, which is the start, the middle, and the end. So first, let's check if he doesn't find the element, which is walk node, which is, let's actually put node this time because he's not walking. If node equals to null, we return false. We just return the element here. Now, if it's not null, what we do is we have to handle the situations. So if it's in the start, I think we have a problem here because I'll need the node that's before this one, and I cannot get the previous node because I'll have to handle this, because to eliminate a node here, I'll need to disconnect him from the previous and the next one. If it's in the end, it's easy. I'll need the previous actually. If it's in the end, I can simply just say this dot start equals to no dot get next. I can just do this pretty much. He's gonna just jump to the next and he's eliminated. But in the end and in the middle, I'll need to actually handle the previous and the next. So this is gonna be a problem because here, damn it. So I'll need to actually look through the fucking list. I thought this would be helpful, but it didn't. That's okay. Let's clean this up and go back to the walk node. Walk node, go back. I think you can clear it here. Let's put here var back or var. It loops through the node. I'm not returning anything here. Once he found it, we do how do I take the previous node though? I'll need a temp node to hold the previous in case, because I don't have any data about the previous also here. So I'll need another var called temp. It's new. Var is not inferring the information, so it needs to be a node here. Yep. That's good. So here all I need to do is before I need to do temp equals walk node. So this way you can save the information of the previous node in case it's in the middle or if it's in the end. And let's remove this return here. So okay, we have the previous node. Actually, let's call it previous node. I think it's gonna. Oh, I should. And that's better. So we call it previous node. It's gonna be easier to identify what it is later. So we have the previous, we have the walk. Do I need something else? I can get the next by doing this. So the moment I found it, I'll need to... What do I need to do? I'll need to check. So we're treating here the middle case because the start case I think is not going to fit here. And the end case will also not fit here. The moment I found it, I'll have to. The problem is that I don't have the previous node here. Actually, the previous node is no. So if shit, previous node equals to null, what it's gonna do is there's no previous is because it's the first element in the list. So I would do this dot start equals to walk node dot get next. So this will eliminate. Let's eliminate the first element in the list. Let's make just let's think the execution here. So if it gets here, if there's no previous node, it's because we're in the first element, because here's the start. And here, if we're in the first element and is equal, we just change the start of the list to the next element, and they are not connected anymore. We'll have an address in memory that is pointing to nowhere, that is inaccessible here. I don't know if I should do this here, like walk node dot set next. Nope. I don't know if this is a good practice or not, because if we don't do this line here, what will happen is that we have an element in memory that's going to be pointing to nowhere, because he's not going to be, we're not going to be able to access it anymore. But I'm not sure if I should do this here. I think that's actually a good idea. So the element before, no, actually when you set the next, so he jumps to the next, and I'll set the next to null. Well, let's just leave it like this for now. Okay, so if it's not the first element, so else, if it's not the first, is because it's in the middle or is in the end. And if it's in the middle, what we're gonna do here is I need to the previous element in our walker node is in the it's kind of confused to visualize. So our element is gonna be, so actually what will happen is that previous will have to point, yeah, actually this previous will have to point previous dot next. Oh shit. Set next will have to point to this guy. Actually, let's draw this. I think this is getting complicated. Let's open a Whimsco here. It's not Whimsco. What's the name? It's ColorDraw. Yeah, it has stuff here. So let's get a rectangle here and duplicate this. Oh shit. Duplicate it a couple of times just for me to visualize this. Okay. Let's fill them in like black or something. What is this line? Okay, that's fine. Easier to move around. So right now, this is your previous element. And this is a walk node. And we have the walk node dot get next. So what we're going to do here is, let's put an arrow. The current situation is this is pointing to this, and this is pointing to this. So what we're going to do, actually this, okay, this is right. So what we have to do is this guy here, this is so ugly, what the fuck. This guy here has to stop pointing here and start pointing to the, oh my lord, this guy. Okay, pointing here. And I think that's it. We need to point this guy. You simply, this connection here has to jump one node and go here. But what about this connection here? This is what I was talking before, because this connect here will keep existing. So maybe we need to figure out a way to cut this off, to like remove this connection here, so we don't have like a memory useless element here. But I think this is gonna work. Like you point this element to the next, and we like, what do we do with this guy? We point, yeah, we can like do like point the walk node dot next. This is good. This is making me confused, but I think this will work. So we do here is set next to walk node dot get next. And this will do the jumping here for us. And we also need to handle the end. This is going to handle the middle situation. So this here's the removing element from the middle. Actually, I think this also will handle the no too. Because if the next is no, actually let's draw this again. No, this is okay. Let's put this here. If the next element is like no, and this here is pointing to the no, let's put it here. Let's make it bigger. Good. What I'm gonna do is I'm gonna pick this up and just point here. I think actually this solves the problem of the end of the list too. Huh. Let's see if it actually works. So let's go back here and clean this up. Let's clean the whole thing. Actually, let's just leave the one print here so we can copy and glue it. Copy and paste, actually, not glue it. This, so first things, what we have to do is here, let's make some testing, is the basic test, which is removing an element from the start, removing an element from the middle, and remove an element from the end. Yeah, this would be your basic testing. I don't know if this would be like boundary testing. What's the name of the technique in English actually? Let's see, Control K. Boundary testing. Let's see. Software boundary value analysis. It's boundary value analysis. It would be something close to boundary value analysis. Not exactly it, but it's fine. I'll need this, I'll need this, and I'll need this. And I'll also need to print the list. I was printing the list before, actually. Let's copy this. I was printing the full list before. I was just printing the... Yeah, okay, that's fine. Take this off. The two, and I'll print R, string R. I need to print, actually. No, I will do the printing because I need to see if it's true or false. Dot remove. Let's remove Tiago. And see if it works. So I'm removing the first element. So we should go inside of here, this first if. Let's give it a try. Run. Why is this taking so long? Come on, run it. So we have Lucas, Taylor, Anna, and Julio. Good. And we have a false. Why do we have a false? False. Oh, because we didn't return any truths in any point. Yeah, that makes sense, actually. What happens if I do this? I think nothing will explode. I believe. Let's see. I'll not print this guy's useless prints here. But we lose the last. That element is gonna be like lose somewhere. And we have a problem. Is no. Oh, okay. So this is something blows up. Oh, so I'm checking here. So when I change it to no, when I get here and it changes to no. Actually, if I return true here, we're not gonna run into this problem because. Oh, actually, not true. Actually. If I return true here, we're not going to run into this problem. You got this exception off. And we would have a true, and we have a Lucas and a Julio. Oh, that's good. Now let's move this guy down here. This thing is so annoying. Why this thing keeps appearing out of nowhere? Well, actually, not this. What I want to do. Wait, what? There you go. So in the middle. So let's delete this Taylor here. And see what happens. So what you should show for us is the Tiago, Lucas, Anna, Julio. Let's see if this works. So Tiago, Lucas, Anna, and Julio. Nice. But he returned a false because of the same problem before. We didn't return a true here. Let's put a true. Hey, are we returning true a lot? I think we're returning true in a lot of places. Which is not good. Yeah. Let's see if it works though. So this working here again, moving this down here. What we expect here is, let's put an expected this time. Let's copy this just for the fun of it. Oh, no. Need an extra one actually here, which is Taylor. Okay, Tiago, Lucas, Taylor. So our expected value is this to be off because we're removing the last element. Wait a minute, what the fuck? Oh no, it's building. And we have a problem. Because Anna and Julia is still here. That's bad. So this was not enough to handle the previous. I think what is happening here is once we go through all this, let me think. Once he realizes it doesn't have a next element, it doesn't run to the loop. So when it gets to the last element, it doesn't do anything. Actually, he's not going to the end of the list. I shouldn't check if this is close to no. This is never true. Always false. But I'm getting the next here. Actually, it should be a while true, so it should be different than no. He's gonna get into no here. Now he will loop through everything, I believe. Because when I do his next and it gets no, it never gets to the last element because the next element of the thing is no, so and no is an invalid value. Let's see. Oh, now I removed Julio. That's good. Actually, this is a good thing to remember because up here I did the same thing here, so he's not gonna loop through the whole list. This is bad. That's why we do testing, guys. That's why we do testing. So now it works, and let's see what happens if I put an element that is not in the list. Or, like, Gabriel. Or an empty value. And then this, and no, putting on my tester hat just in case. So we have a bunch of falses in here. That's good. Actually, that we have to check the expected. Wait a minute. So this is thing. This is the full. Gabriel false. Empty string false. No, no. And I cannot send. What else can I send here? Can I send an? Let's go crazy here. Why not? Object. Oh. Cannot do that. Let's try. Let's do a new object. He doesn't accept this. Yeah, it's need a string. That's good. I think it's not a problem. We're gonna do some unit tests on later, just in case. But this is looking pretty good. So we have. Let's remove this comment. Actually, let's see. Is there some optimization I can do here? It's kind of working the way I want. What is this here? It's showing something. Common part of from if. Extract common part from if. Common part from if. Wait, what? Oh, okay, he's seeing that it's true in both cases, so he's moving this guy down. That makes sense, actually. Actually, he made it prettier, so let's just use the distractor. Yeah, better. So maybe the code could be better though. Let's do this. Okay, the code is not perfect, but remove the comment here because my code have to explain itself for it to be good. We'll return false here if it's no. I'm while looping through the thing. I'm checking if the data is equal, if the previous node is new. I'll just set a check here. Check this later. I don't know if it's a good practice or not. Actually, let's check it now. Let's ask GPT about it. Why not? Let's use AI for good. Let's put here GPT. Let's whip some of the AI in the back. Let's put a question here. Let's see if he picks up. Is this a good practice? Practice. Let's see if he picks up the question from the code comment. If he doesn't pick it up, I can just say answer the comment and see. Stay logged out. Remember to implement remove from slightly. It's correct. I'll go through important parts and answer your specific question. Okay. The question is a good practice? Short answer, not necessary, but sometimes acceptable. So it's not necessary. Why it's usually unnecessary? After this line, there's no reference to walk node anymore. So the garbage collector takes it. Oh, that's cool. So I don't need this shit. So this worked fine without the when people do it intentionally. There's a spelling problem. There's a spelling problem. Fuck. Sometimes developers clear references to help GC faster in large data structures. So it can. So it's not wrong, but it's not necessary. Well, let's remove this. This is gonna make it more confusing. But it's cool to know. And I made a. Oh, there's a clear version. I don't want a clear version. Not yet. Not yet. We're not using AI yet. Wait. What? What is wrong in previous? Previous? Wait, no way. There's no way it's written previous. Previews? There's no fucking way. Oh, I hate GPT. I'm kidding, GPT. I love you. No way this thing's previews with an E. What the fuck is wrong with English? What the hell? Okay, guys. I think this is enough for today. This video is getting a bit long, so let me hear your thoughts in the comments below. Bye. Have a nice day.